Hello, this is TKMaths. Today I will explain you question number 9 of TKMaths exercise 4.3. The chapter is about quadratic equation and expression. In this question it is said that if this equation has real solution, then show that the values of p cannot lie between this. So let's see the solution here. This is the equation, and question is saying if equation has real solution or real roots. It means we will take discriminant greater than or equals to 0, and then we will see do we end up at this answer or not. What are the values of p do we get? If we get what it is said here, then it means the equation has real roots. Okay, so now I'm rearranging the equation here, expanding the brackets here, and then removing the brackets, and then rearranging in the form ax square plus bx plus c, which is the general quadratic equation. And we know coefficient of x square is a, so I'm writing a is equals to p, and the coefficient of x are b, so here it is minus 2p minus 4, and the terms without x are called constant, so my c is minus p plus 10. Now it is said if equations has real solutions, then discriminant is greater than equals to 0. So I am substituting the values here. B is minus 2p minus 4. A is p. So I am substituting the value and then I will expand. Now what I have seen, students mostly make mistake in this expansion. They do not have a clear understanding of this. So let me explain you here. You must know that the expansion of minus 2p minus 4 whole square will be equals to the expansion of this. Let's see how. We all know the algebraic expression a plus b whole square, algebraic identity, that this thing is equals to this, which we learn in class 9. So now if we see the expansion of this stepwise, square means twice I am writing it. So now if you multiply minus a by this and this, you will get plus sign. Then minus b by this and this, you will get all plus. So it is eventually a square plus 2ab plus b square. So the important thing to remember here is that for algebraic identity, minus 2p minus 4 whole square will be equals to plus. So I will expand it by this formula. So now let's see here. So now it means it is 2p plus 4 square. So by the formula I am expanding it here. And then this is simple, you can expand it easily, and then you are simplifying it here. After simplification, which is just plus minus, you end up at this equation. I'm dividing it by 2 to simplify it. And now I will factorize this equation. So now here is the factorization of the equation. Now your equation is in terms of p. The coefficient of p square is plus. It means it will give us minimum value curve. And this factorization form tells you that your p-axis will be intercepted by at the point 2 and 1. I hope there is no confusion about it. Now because the coefficient of x square is plus, it is a minimum value curve. Now again the confusion is what roots it will be. So I will repeat. Which are the values of p you will plug in here so that your this answer is greater than or equals to 0. So graphically if I see, because this graph is representing this equation, so which are the values of p you will plug in here so that your answer comes positive. This is your origin, so all these answers are positive. So these are the parts of the curve, this one and this one, which have positive values of y. So for certain values of p which you will plug in here, you will get positive value. So these are the values of p on this part of the curve, which will always give you positive value for this point of view. So values of p are this. And similarly for this part of the curve, because it is above the p-axis, right now my axis is p. So all these values of p which are less than 1, I will have the answer greater than 0. So I'm writing here p must be greater than equals to 2 or p less than equals to 1, which means it is proven that p cannot lie between 1 and 2. It is either greater or less. So this is what we had to prove, that p cannot lie between these two if it has real roots, and we started with that assumption. Thank you. I hope this explanation is clear to you, and if you have any query, you can send your mail to my email address, which is tkmathsisfun@gmail.com. This is given to you in the description. Thank you.